Hey, one quick, kind of unfortunate announcement I have to make. There's been quite a few students who are posting code on Piazza. Please stop. It's, sharing code with another student in the class, that's an academic integrity violation. Posting your code publicly for the entire class and all TAs and myself to see, obviously an academic integrity violation. Please stop. Unfortunately, so I've given this warning in all the lectures. There's a Piazza post. We're done with warnings. If people continue to do this, I'm going to have to start handing out Fs for violations. It's unfortunate, but come on, what are you doing? Some of you, probably, maybe none of you in this room, but some people are still posting code to Piazza. Stop. Why do we even have to say that? Anyway, on a more positive note, let's get into this. Objects in classes, we have quite a bit of content to go through today. There's quite a few topics, so let's jump into this. The lecture question, we want to be able to write a class that we're going to use to create create objects. And these objects are going to take a list of strings in the constructor of the class. These strings are going to be the options that you can vote for. We're going to write two methods to be able to track votes. Somebody's reporting votes for a particular option. Those should be all summed up. And then get votes, how many total votes were there for each option. And if we're getting the votes for a valid option that's not valid, return 0. I just updated the slides. I thought I updated this with this line earlier. I didn't, so if you had the old version of the slides, it is 0 if we don't return an option. Don't return that. And then, of course, the test suite. Create objects of this class and test the functionality listed above. So, what does any of that mean? I use a lot of words in there that shouldn't really make sense unless you've done this stuff elsewhere. What's an object? What's a class? What does creating an object from a class mean? Well, what does any of this mean? So let's talk about it. Let's go through today's lecture and figure out what I just rattled off of that lecture question actually means. Constructor too. I said constructor. What does that mean? What's a constructor? So let's talk about objects first. We've been working with objects in this class so far. We haven't talked about state, which we're going to start talking about today, but we have talked about behavior and functions. We wrote objects that had functions, which is a nonsensical line, because whenever we have what we think of as a function inside of an object, we call that a method. And there's subtle differences between the two. Mainly a method has access to the object's state and the reference to the object itself. So we've done this. Every lecture question has been write an object that has some method that does whatever. But objects can also have state, which are variables that can change with that object. So these variables, any variable defined outside of all of the methods, are going to be part of that object's state, and the state can be accessed by all of the methods in this class. So if I have these variables outside of all the methods, that becomes the state, part of the state of that object. We can access these variables using the keyword this. If we do this.x from inside the object, it's going to access its state variables. This is usually optional. We could do x star equal 2 and have the same exact behavior, but it's good practice to always use this dot when accessing the state variable of an object to make it clear that you're either accessing or modifying the object's state. But we have these variables, we can change them, we can access them, and they're part of the state of that object. Worth repeating, but I've said this before, var, if we declare a variable a var, that means the value can change, so x and y. These can change along with the object. This internal state of this object can change. I feel like I said the same thing 4 times there. And val means that it cannot change. We just want to declare a value that cannot change ever. So that'll come into play with our objects in classes for sure. If we try to change the value of a value, it's going to give us an error. We get an error, install it, and our code doesn't run. These state variables, these variables inside the object, go by many names. I'll stick to state variable because we'll talk about, I want to draw the connection between state and these variables. We're also going to learn about the state pattern later in the semester. We're used to thinking these as state. That helps that part of the course a little bit. But if you've heard fields, instance variables, member variables, and there are a few other names people like to call these things. I don't know why they have so many names, but they do. These all refer to the same thing, any variables that are part of that object and outside of any of the methods. these variables, the state and behavior of a method of an object, can be accessed from outside of this object. Now, so far, normally we've been accessing the behavior. We've been in the testing saying object name dot method, call this method, make sure it returns the right stuff. But we can also access the state of an object. So if I say object with state dot double x, that's going to call double x and actually change the state of this object. And then if I print that state, I'm going to see that state. Every value in Scala is an object. I'll say that quite a few times throughout the semester. So if we have this main method, I'm going to run this. From outside, bless you. From outside of this object with state class, we can actually modify this variable x. We can make changes to this variable from the main method. We print x, we get 10, that's its initial state. We call double x, and then print it x again. That internal state did change, and we can do this from anywhere in our programs. So if we have an object, and some of our code over here is changing the state of that object, some code over here is reading the state of that object, those changes are going to be reflected in our throughout our program. So something we need to be aware of. And we can do things like, oh my goodness, my fingers are on the wrong keys. Object with state dot x equals 1,000. We can just change those values as well. So we have full control of access to variables from outside of that class definition. This is where normally we would have our import package name dot object with state. Since these two classes, these two objects are in the same package, we don't even need our import. We can just start modifying the values with that. And we've seen this syntax before. If I do like math.abs, that's the same syntax. We're going to the math object, accessing its ABS behavior. And here, we're not worried about any state of the math object. It doesn't have any state, but we do want its behavior. We want its methods, so we can start doing some math on it. And technically, if you really want to call me out, because I tried doing this in the last lecture, math is a class. It's a Java class with static methods. Nobody cares about that, right? Anyway, technically, that's what's going on. But I do want to show you this string class. So string is a class that we've used quite a bit. We've created objects of type string, which I'll talk about classes when we go back to the slides. This actually uses Java string. There is no Scala string. It just uses Java's. But we can see the definition of this. We can see that string has some state, which is, this is, again, Java syntax, but this is an array of characters as its state. So a string has that underlying array of characters. That's the state of the string. In a variable named value, technically a val if we're converting this over to Scala. And if we have things like, say the split method, oh yeah, this is it. Bless you. So we have this split method. This is going to, oh, what a mess. This is going to look at that value. It's going to look through that char array and look for the values that we're trying to split on, create new char arrays, throw those into new strings, and then put those strings in an array of strings. It's going to look through that internal state in that character array and do whatever functionality we want to call with that. It's going to do all that stuff. It's going to return, some complicated looking code here, unfortunately, but it's going to look for that stuff and do the functionality we want. So this is, the string class is used to create string objects with an internal state, which is that character array. Then the methods that we call on that string are going to look at that character array and give us the behavior that we want. But I'm using the word class there. And just So I'm using that word class. Well, what's a class? We only know about objects. A class is going to be used as a template to create many objects. So we don't want string defined as an object. If it's defined as an object, we can only have one string in our entire program. Anytime we reference that string, we're always referencing the same array of characters, and we can only have one array of characters at a single time anywhere in our entire program. That's not the behavior we want. We want many objects of this type string. So when we have that scenario, we create a class, and that class is used as a template to create many objects with the same state variables. So every string object will have its own array of characters, and similar behavior. It's going to have all those methods defined in the class. It's going to have all of that state and behavior, but each object of that type can have different values stored in its state variables. So let's create a class. Say I have a store. I have a lot of different items in my store. I don't just want some object to store my items. Say I want to store description, price, and track the number of times purchased for an item. I don't just want one item type in my store. I'm going to create an item class, and now every time I put a new item on my shelves, say I get something in stock that I want to put on my shelves, I'm going to say, here's its description, here's its price, and then the times purchased is going to initialize to 0, and then I might have like 20 of that item type, and then each time I sell one, I want to be able to track how many of them I sell. So I want a class that's going to let me create multiple objects of this type item. So I want multiple items in stock on my stores, then track the times purchased for my accounting and to see when I need to reorder my stock and all that stuff. I want to track how many times it's been purchased. So let's look at the syntax here. The first thing, we're going to use class instead of object to create a class which is going to be used to create objects. So a class named item, and the body of this is going to look very similar to the objects that we saw. It's going to have the same syntax. We're going to have variables outside of all the methods, which will be state variables, and also methods which are going to define the behavior of objects of type item. When I create objects using this class, they'll have this behavior, they'll have this state variable. So all these are the same. We have the keyword this to be able to access the state variables. And we have methods with side effects. And we get all that same good stuff that we had with objects. The new thing here is what's called the constructor method. This is a special method that's going to be called when we create new objects of this type. So when we create an item, we want to know two pieces of information in this case. I want to know the description, and I want to know the price. In Scala, any variables, any parameters that are in the constructor call will become state variables. I don't have to use any extra syntax here. Anything that's in the constructor will become state variables. So for example, on sale, I accessed the price variable, but I don't have that as a state variable where we've seen them with objects. Whenever we have a constructor parameter, that will be a state variable. So var price of type double, that's the same as if I put it down here, except when I put it in the constructor, I'm saying this is something the user can specify when they create new items. They can give me the description and the price, and I'll remember that description and price. But times purchased, I'm not going to let anybody initialize that to something else. That's always going to start at 0. So I'm not going to give anyone access to that in the constructor. I'm just always going to initialize that to 0 for any object of type item. And this is where val and var are going to come in. If you don't put either val or var in the constructor parameters, anyone outside of this class won't have access to those values. So when in our main method we said object with state.x equals whatever, access that. If we don't use val or var, whether it can be changed or not changed, if we don't use one of the two, outside of this class, nobody will have access to those state variables. They'll only have access to the times purchased if I left val and var off of this. Which, depending on the behavior you want, might be fine, might not be. It's just what behavior you want from your classes. But if you want access to these outside, val or var. depending if you want values or variables. All right, any questions at this point? I'm throwing a lot at you in this lecture, so let's take a little time out to digest. Any questions at this point? Nothing. Oh. Any questions about last lecture's lecture question that caused quite a few questions, quite a few issues? Anybody have questions about it? Nothing. Well, let's keep on trucking then. If there are no questions, let's get some more content out there. All right, so we got these classes, but so what? Oh, yes, thank you.
So, how would you? So we can create multiple objects just by. So if you go back a slide. Sorry.
Mm-hmm. Yeah, no, I'm listening. I'm just fighting with my thing here.
How would I create an object out of it? Just put a name and then it would be dot item dot one of those methods.
So you're actually asking exactly what's on the next slide.
Okay, yeah.
So I'll answer you and just segue into the lecture. Bless you. So we're going to use the keyword new. So we have these classes, so what do we do with them and how do we create objects with this new class? So we have a class named item, and I said, now we can create a lot of classes of type item. How? We're going to use the keyword new and then call the constructor. The constructor has that name equal to the class, and then we would need to give it whatever parameters we defined in the constructor. So I'm going to say new, constructor call, give me a new item, and I want the description here to be cereal, and I want that to cost $3 in my store. That's going to give me a new item, and item is a brand new type in Scala. What we did was create a new type. So we have ints, maps, arrays, lists. These are all types in Scala. Those are all defined by classes. We wrote a new class. We just defined a new type. So now we can have objects of type item. We can have variables of type item. We can have parameters of type item. And I don't have one on the screen, but we can also have methods that return objects of type item. We can use these anywhere. We can use any of the other types. We just defined a whole brand new type in Scala through defining a class. So all those types that we've used, there are classes associated with them. You can go to the code, look through them. Most of it's really cryptic code like you saw with strings. But those are all classes that are defined. We just defined a new class. We just defined a brand new type. So I'm creating a new item. So I have an object item. I'm storing it in a variable of type item named cereal, or here, not variable. And I'm going to create another new item of milk. I want that to cost $2 and store that in a variable named milk, a value of type milk. A value named milk of type item. These two items that I just created each have their own copies of the 3 state variables that are associated with this class. So milk and cereal each have their own description, which are milk and cereal, their own price, $3 and $2, and their own times purchase variable, which are both 0 at the time of creation before we start calling purchase. So each of these objects has all 3 of those variables and has their own copies of all 3 of those variables. When we said new, what we got were 3 new variables all wrapped in this one object, and also all of the methods attached to that object. So now we can say cereal, purchase, on sale, purchase. We can call these methods. We have the behavior attached to that object that we created. We can access its variables directly. I want the description and times purchased. I can access those. I can use them as arguments in a method that takes values of type item. And in that method, I can access description, price, all the state variables. I can access all of that stuff from outside of these classes once I have them defined. So I have these 2 objects, and I'm using them just like we saw the object, that object with state earlier in the slides. I'm using them the same way, but they both work independently of So when I So when I run this code, when I run the example, mostly verbatim from the slides, but I added a little bit to the bottom. When I run this code, I'm purchasing cereal twice. When I print out the times purchased, it's going to say cereal has been purchased 2 times because I called purchase twice. Each time purchase is called, it's incrementing that times purchased variable associated with that object. So I increased times purchased of this item stored in the variable cereal twice. When I print that out at the bottom here, I get 2. We incremented that twice. But when I print out milk times purchased, on that particular object, that times purchased variable attached to that object has never been modified. I never called milk.purchase. So this times purchased, that's still going to be 0. These 2 objects do not share variables. They just happen to have variables of the same name, but those variables are not associated with each other. We created 2 completely new objects, completely separate of each other. Their states can vary independently. And this is how we get things like different strings throughout our program. I can have 2 different strings in a method, and those strings can have different arrays of characters stored in them and have different behavior because the state is different. But they don't share that array of characters. Same thing's going on here. They don't share their times purchased variable. They don't share their description. They don't share their current price. And as we see here, might as well mention explicitly, we can modify these variables directly too. We can just set the price of milk to $1.50 if we don't want to use that on sale method. If we don't want to make it on sale exactly 20%, we can just modify the price directly from outside of that object. Any questions here? While we're in the code, I can run some different stuff. Any questions on this whole example? All right. References. We will talk about this at length all next week. So obviously this is a big topic, references. I just want to give you a quick intro to it today. But obviously this is a big one. It's one of the bullet points in this learning objective. And we're going to talk about references and also that third bullet point, the stack and heap memory. We'll talk about those in conjunction next week. So sort of 2 very related topics. So let's get a quick intro. What do I mean by reference? Every object you create through a class that you wrote is going to be passed by reference. And I'll put my asterisk. Technically, it's passed by value, but the values are references. I'll refer to this as passed by reference just because that's a mouthful. Technically, when I say passed by reference, it's wrong. So if that matters to you, it is passed by value. Values are references. I'll say passed by value in this class. So these will be passed by value. Also, any of some of the classes we've seen, the data structures we've seen, list, map, and array, these are all passed by value as well. So what does that mean? Or passed by reference as well. So what does this mean? It means that if I have a method that takes one of my types as an as a parameter, it's not making a copy of that object. It's actually giving it the entire object itself. So the entire object is passed, and any changes made to that object in the method are reflected outside of that method as well. So there's no copies being made where, for example, like an int, you're making a copy of the int and passing it, you're passing the value of the int, not the reference. And then if you change that parameter, which you'll get the can't change a val error anyway, but those are values that aren't affecting anything outside of that method call. So what do I mean? If we have this method that takes an item something of type item as a parameter, and I call this with this item that I created. I'm creating a new object of type item, and then calling this method. What I'm doing is actually giving this method the entire object. I'm not making a copy of the object and handing the copy to the method. I'm giving that method my entire object. So when increase price, this method says item.price plus equals 25, that change is reflected in the serial variable as well, because they both refer to the same object, and we're just passing that reference to the method. Same as if we do an assignment like this. If I create a new item, new variable of type item, and just set it equal to my serial, that equality, that assignment, is happening by reference. This is the same thing that's happening in the method call. Technically, we have item of type item equals serial is what's happening when the method's called. Our parameters are being assigned the value of our arguments. Same thing's happening here. We're doing this by reference. So serial 2, when we increase the price of serial 2 and give that to item and increase it by the price by a quarter, we're actually making those changes to the same object that's stored in the variable serial. So the price of cereal is now $3.50. Even though we've never said cereal.price plus equals anything, both of those changes occurred in that same object. Oh, I added to this one. Oh no. I changed this example too much. Okay. Here's what I want. So when I run this code, when I call increase price with serial, increase price is increasing the same item. There's only one item that I've ever created in this code. So any variable type item has that same, is storing that same item that I created in this call to new. So when I call increase price, this item is being passed and increase the price. This serial 2 refers to the same thing, increase price, increased by a quarter. Serial and serial 2 are both $3.50. They both are referring to the same object. So any change made to one is reflected in the other. And this is because they are being passed by reference. We're only reassigning a reference. We're only passing a reference. We're only passing a reference. Serial and serial 2 are, those two variables store references to the same exact object. So they're referring to the same state variables. I have two kind of one-off topics here. If you're getting started with Physics Vector, with Physics Engine, you're going to see the Physics Vector class. If you haven't already, if you haven't looked at this one, or if you're doing Rhyming Dictionary, you probably haven't seen this. But there are a few things in here that you're going to see that I just want to point out. So one, we have these equal some value right in our parameters of our constructor call. And you can do this with other methods as well. What these are default values. So if I don't always want to specify x, y, and z for a physics vector, which I don't, I can have default values and only give it the values that I want to assign. So for example, if I do physics vector of -6, x is going to get the value -6, and since y and z were never specified when I called the constructor, they're going to revert to their default values. So I get -6, 0, 0. If I don't give any arguments, all of them are going to default to their default values. I'm going to get the vector 0, 0, 0. This is usually convenient if we don't always want to type, like if we want this behavior and we don't always want to type those extra zeros. Saves us some time, saves us some effort in these constructor calls and then general method calls. The next thing you see is that ToString method. So if we want our objects to be printed in a more friendly way than the default, which is just some garbage. It's just going to give us the hash value of the thing. We can write this ToString method. We'll talk in a few weeks about what this override really means, but for now, if you write override def ToString colon return type ToString, and then give it some method body, this is what's going to print to the screen when you do a print line will implicitly call ToString, or if you just want to convert your thing to a string through ToString directly. So this is going to give us the structure of a vector that we're used to, where we have parentheses and then x comma y comma v. We want that format. So when you have your test cases and the test case fails and you have your hint text, you would rather see what the actual values are of that vector. You actually won't get x, y, or z if you don't have this ToString. So that ToString's there in the physics vector class, so it helps your testing and your visualization of what's going on with the program, what those values are. And while we're talking about physics engine, one warning on this. So we're talking about references. I haven't talked about them in a few minutes, so let's remind you what references are. Let's talk about this again. So in the physics engine assignment, one of the objectives is to update the location of a velocity, but also remember its previous location. So we want to update, we have the location of an object, and we have some velocity and some delta time, and we want to update the location based on that velocity and delta time. But we have to remember the previous location, so we want to know the location before and after this change. That is part of the assignment. So what we're all tempted to do is this line right here, previous location equals location. So I have my previous location right here where I started, and then update the location using my velocity and delta t, and update that location there. Problem is, this assignment happens by reference. So physics vector is a class, it comes with the assignment, but it's a class we created. It's going to be passed by reference, so when you update the location, it's going to update the previous location too, because they refer to the same object. So if you have this line of code, functionality is going to be broken. It might be pretty hard to find out why if you're not looking for this specifically. So what you want to do is previous location equals a new physics vector, and then pull the x, y, and z from that current location. So you can get around that pass by reference. So that's not the behavior you want in this particular case. And we've seen classes before. We've seen lists in this example. And we've created new lists. But I said to create a new object from a class, you had to use the keyword new. But list, map, array, they seem to defy that. They don't make us use the keyword new. There's nothing too magical going on, well, maybe a little. But this is just something the way these classes are set up, we don't use the keyword new. They're actually set up with companion objects where the object has the same name as the class, and then that object has a method named apply, which will store a constructor for that class. Once you set it up like that, you don't need the keyword new, and you call it like this, and then the apply method will call new at some point to actually create the new object. New is still being called somewhere, just not by us in this case. So we don't always have the keyword new, but we are doing the same thing. We're creating a new object of type list using the list class and calling the constructor, which takes any number of values of the type of the list we want to create. Same thing, same ideas, just set up in a way that we don't use the new keyword. So if you're wondering why didn't we use new for those, that's a brief explanation of why. Suffice to know that we just don't need new for certain things that are set up to not need new. But we are still creating new objects from a class. And I have to mention this. If you're coming from Java, a lot of you, if you've done programming in high school, you've seen Java. I know I feel like I say this all the time for those of you with Java background. But at least one more thing for those of you with Java background, or if you don't have Java background, you'll still find this interesting, I think. Access modifiers. If you do have Java background, you're probably wondering why I haven't talked about access modifiers at all. You didn't see any access modifiers in my code. I'm talking about objects and classes and states and methods with no access modifiers. There's no public, private, none of that. Or C++ if you have that background. I haven't seen any of that. Why? And you're probably pretty mad at me by now. You're actually not going to see access modifiers in this class. There are access modifiers in Scala, but it's kind of pretty much convention to not use them at all. I won't use them at all in this class. And these are actually controversial. Access modifiers are not be all end all. You either use them or you don't. Across different communities and different languages, across the communities, there's not much agreement on whether we need access modifiers or not. So for example, Python and JavaScript in 1.15, access modifiers are not even part of those languages. They don't even exist at all in those languages. So if you think access modifiers, or if you've heard this before, access modifiers, you need them, they're so important and everything, well, those people probably don't like Python or JavaScript if they're saying that, because they don't even exist. Everything's public. You can't restrict access at all. There are some workarounds in JavaScript. There's some kind of conventions in Python. If you name your variables a certain way, it communicates to other developers that those are private variables that they shouldn't be messing with. And some IDEs will remove those from the autocomplete, so it doesn't list those as options that are easy to access. You can still access them and change them, but just some conventions to show other people. In Java, we have public, private, and protected. Public means anyone can modify this variable. Private, modify or access. Private means only this class itself can modify or access this variable. So only inside the class definition can you access that. So even once you create an object of the class, you can't change, you can't access the private variables. Protected means only classes that extend that class or are in the same package can access it. Then package private, the default means only classes inside the same package can access those variables. Even if another class in another package extends this class, it still can't access those variables. Scala has private and protected, and default is public. There's no package private. So default is public. We just say everybody by default has access to everything. And that's what I'll stick with. I'll stick with the default. Everything's public. If you're coming from Java, you've seen lots of code like this. Java and C++, those communities say every state variable must be private. Do not let anybody ever access your state variables directly. And then write getters and setters or accessors and mutators to be able to allow people to access that state. If you've written Java, if you've taken a Java class, you've seen this. When I teach Java, I do this. It's the Java way. That's how we do it in Java. Scala in this way, say you write a class, and X can be anything you want it to be, and you're happy with that. But then later on, you want to make an update to your program and say, whoa, I don't want X to ever be negative. When it's negative, that just breaks things. I have this code over here that assumes X will always be negative, and if it's will always be positive, and if X is ever negative, it just completely breaks everything I'm doing. Well, if your users, other developers, I should say, are accessing X directly, you have no guarantee that somebody somewhere in this code base didn't say access modifiers or some instance of this .x equals -3. You can't stop them from doing that. So the answer is to write a setter method, and not when you want to make that change, when nobody has access to X, but in the setter you say if this input X is negative, handle this, set it to 0, whatever you want to do to handle that situation. You can put that right in the setter and take care of those problems right in the setter method. The way Scala gets around this is it has special syntax. You can write setter and getter methods after the fact. So if I just say I want a state variable named X, and later on down the road I say, oh, I can't let this be negative ever. I write a setter method using special syntax. It's like _X and then the inputs. With that syntax, now whenever someone somewhere else in the code has .x, the syntax to access X directly, it's actually going to replace that with the setter method, just by the special syntax that's built into the language. So we can always write getters and setters later on in Scala and get around the same problem that getters and setters in Java are preventing, but Java will not allow us to create a method named .x and replace the access with .x. So it's a little lore, a little background there. But that's why, if you're wondering why we don't do this in Scala, it's because Scala has us covered. Scala did some work built right into the language for us to avoid this writing everything in triplicate like Java has us do, which Java should. That's the way Java's set up. Java didn't address that problem fundamentally in its design, so that's how you should do it in Java. Scala, we don't have to. We're back to the lecture question. So are there any questions at this point? Yes.
Can you overload constructors and methods in Scala?
I believe you can with the companion objects and the apply methods. Can you overload for Twitch? Can you overload a constructor? I believe you can with the apply methods. You have to do it that way. Otherwise, we have the default options, and we can specify which default options we want to override to kind of simulate multiple constructors. Yeah, I think you can have multiple apply methods in the companion object if you want to go that way. Any other questions? So we actually have a little time. I didn't have time in the other one, so you get a little bonus. Let's see specifically how to test these things. You have to do some testing in the lecture question. So let's try to do a quick example of this. Test item. So if we want to test this item class, and if IntelliJ cooperates, looks like it will today, let's create an item. Let's just stick with the item. I won't get creative here. New item of food. What should the item be? I'm blanking on anything creative. Onions. And onions, let's say, are 50 cents each. Is that a lot? 30 cents? 30 cents per onion? I don't know. I just throw them in the bag and put them on the scale. I don't pay attention. But we have to import our class. We're going to import this week2.objects.item, so we have access to this class. We're creating a new object of that type. If we want to start testing this behavior, assert item dot, oh my goodness, typos. Assert item dot description equals onions, because that should be onions with capital O, so that would have failed. But we can access these variables and test those variables. This, for the lecture question, you can't do this. For most of the question, you shouldn't do this, accessing the variables directly, because the lecture question doesn't specify what the variable names should be for any of the state variables. So don't access your variables directly, because you're going to submit your test to Autolab, and with almost 100% certainty, I chose different names for my variables than you did. And when your test runs, looks for those variables that you named, well, guess what? Those variables don't exist, and you're going to get past your own code, error on the correct and incorrect solutions. So don't access them directly unless they're specifically defined in the objective that you're working on, because I won't have the same names, unless just by pure chance we chose the same names. But we do want, so the item class isn't really set up for a question, for testing. But let's purchase this thing a few times. And I want to assert item dot times purchase equals 2. That should be a thing. I don't want to do on sale because then I got to set up my whole comparing doubles. I just don't feel like doing that right now. But let's just run this test. So we can call the methods, access the state, ask it what it is. For the voting, you would call submit votes. I forget what I named it. But vote submit a bunch of votes for various options. Make sure you call it at least a few times with each option, and then say get votes. Okay, were these votes recorded properly for all the times that I called it? So you do new vote counter with your list of options, cast a bunch of votes for those options, and then say get votes and make sure the number of votes equal what you would expect them to be with all the votes that were submitted. So with this one, let's run our items. Hopefully we pass these tests. But when you're testing a class, the general flow goes, create an object of that type. I don't really need to assert something right away, but call methods on that object, and then assert that the state or the return value of methods that depend on that state are giving you the correct values. That's how we would test these things. So it looks like things are working good here, at least for my times purchase, and then I would test the rest of the functionality to my heart desires. So I'm convinced that everything's working with this item class. Okay. Any questions with that? Or anything? Yeah, well,
Yeah, lecture question, can the add votes method take a negative integer?
I don't test for that. By the description, technically it can. You can call it with a negative integer and take away votes. And my solution will allow negative votes. That behavior is undefined, so it's safer not to test it. But technically, yeah, you can have negative votes. I mean, just don't. I'm not testing negatives. You don't have to test negatives. I would stay away from it. But yeah, technically, you can have negative votes with the description that I have. All right. Have a good weekend. I'll see everyone Monday.